of a circle. A cone formed for a sector of a circle. When we have a sector of a circle, we can form a cone from it. Remember that we said that a sector of a circle is bounded by two radii rather, and an arc. Two radii and an arc. So let us form a sector, a cone from the sector of a circle. Let's look at it practically how we can form it as I demonstrate it.
So this is a sector of the circle. Look at this is sector of the circle. I told you that the sector is bounded by two radius. This is one radius and this is another radius. So two radii and this is the word arc of this word sector. So we have the two radii and the word arc. Now we want to form a cone from a sector. We want to form a cone from a word sector. To form a cone from a sector, there's something I want to teach you at the end of the lesson. But before that, let us measure the radius of this cone. This sector. Now if we measure the radius, we put from here. If we count, let's start counting. This is 2. This is 2. This is 2.1, 2.2, 2.3, 2.4. This is 2.45. So the radius is what? 2.45. Let's measure it from the other side also to confirm our statement. To look at it also, we have 1, from here to here is 1, this is 2, 2.1, 2.2, 2.3, 2.4, 2.45. Now the radius of this arc is 2.45. The radius of this sector is 2.45. So let us form a sector from it. To form a sector for it, sector is 2.45. So let us form a sector from it. To form a sector for it, you all join the two radius. Join the two radius together. So we now have a cone. This is a cone. We now have what? A cone. Now I want to measure the slant height of this cone. This is a cone formed from a sector of a word circle. Formed from a sector of a word circle. A sector of a circle. So we want to know the slant height of this arc. To know the slant height, let us measure it. We measure the slant height. So if we should measure from the top down to the base, we discover that it's also 2.45. That mark point is also the same thing as the word slant height of the word cone. 2.45. So the radius of this sector, which is like this, is equal to the word slant height of the word cone. It's equal to the slant height of the cone. The radius of the sector is equal to the slant height of the cone. So what you have to know now is that the arrow, this pattern is an arrow, which stands for the radius of the cone. This will stand for the radius of the cone, and it's equal to what? N, which is the slant height. Sorry, this arrow stands for the radius of the sector, and L stands for the slant height of the cone.
So we've just seen how to form a cone from the sector of a circle. How to form a cone from the sector of a circle. So let us look at the relationship. The relationship between a sector of a circle and the cone it forms. The relationship between a sector of a circle and the cone it forms. If you look at from the practical section we just did, we see that we have a radius and two radii and our arc. So we have something like this, which is what this is the what? This arc of the cone, while these are the what? Radius. So one of the relationship is that this arc itself, this arc of the word sector, when we fold it, it now forms this base of the word cone. Let me repeat myself. The arc of the sector, which is this, when we use it to form the cone, the arc now forms the base of the word cone. So the very first relationship is that the length of the arc of a sector is equal to the circumference of the circular base of the cone, which is what I just shown to you from that picture. So what we simply have here, so the length of a arc of a sector is what? Theta over 360 times 2 pi r, while the circumference of the base of a cone or the circumference of the circle is what? 2 pi r. Is that clear? Let me repeat myself. The length of a arc is what? Theta over theta times 2 pi r, while the circumference of a circle, which is the circumference of the cone, in terms of is what? 2 pi r. Now look at this place. We have a bigger r, which is a uppercase R, and a lowercase r, which is a lower we usually call small r. So if you look at it, we have 2 r there. One is lowercase r, the other one is uppercase r. Please take note. This uppercase r is stand for the radius of the sector. It stands for the word, the radius of the word sector. So let's go back. Let's look at it. This R stands for this radius of this word sector. So this is for big R, capital letter R. So it stands for the radius of the word sector. Then let's proceed. Then this lowercase r, it stands for the radius of the word cone. The radius of the word cone, which is the line drawn from the center of the cone to its word circumference. So now let's proceed from that relationship now. So you now understand that this stands for the word length of the arc, and this stands for the word circumference of the word circular base of the cone. So what we simply do now, we have 2 pi here, we have 2 pi here. So what we simply do, we cancel 2 pi, we cancel 2 pi here, we cancel 2 pi here. Then what we have in this side is what? Theta r all over 360, and what we have here is small r, lowercase r. So in a nutshell, what we simply have is that the radius of a cone, the radius of the cone, which is lowercase r, is equals to theta times the radius of the sector of the divided by what? 360. So this is the first relationship you have to know, that the radius of a cone formed for the sector of a circle is equals to theta times capital letter R, which is the what? The radius of the sector divided by 360. That's the first relationship. Then the second relationship, we discover that the radius of the sector is equal to the slant height of the cone. The radius of the sector, which is this arrow, is equal to the slant height of the cone. From that practical section, we discover that the radius of the sector was 4.25. It was the radius of the cone, of the sector rather. Then from the radius of the sector, we now form the cone. We discovered the slant height was also 4.25. So the L, which is the slant height of the cone, is equal to the radius of the word sector. So this is the second relationship. The radius of the cone, the radius of the sector is equal to the slant height of the word cone. That's the second relationship. So let us solve an example. A cone is made from a sector of a circle of radius 14 centimeters and an angle 90 degrees subtended at the center. What is the area of the curve? What is the area of the curved surface area? What is the curved surface area rather? So what is the curved surface area? So what we simply do, this is the sector, this is the radius of the sector, and this is the what? Arc of the word sector. So we need to form a cone. We form a cone. They will still maintain the same what? Angle 90 degrees at the center. Then the radius of the sector, which is 14 meters, is equals to the word slant height of the word cone. It's equal to the slant height of the cone. We were asked to look for the area, is curved surface area, the curved surface what? Area. So we know that the curved surface area is simply pi r L. Pi r what? L. In this, we are given pi as 22/7, isn't it? Yes, that's it. Then we already have the slant height, which is 14. The slant height is equals to what? 14. Now, what we need now is a small letter r, lowercase r. So let's proceed a little bit. Let's proceed gradually. So we have to look for lowercase r. And I have told you before that the lowercase r from the very first relationship is equals to theta times the radius of the sector divided by what? 360. So this is the formula for the what? Lowercase what? R. So let's continue. Yeah. So this is the area of the curved surface, pi RL. We have our L is equal to the radius of the sector, and it was given as 14. Then I told you that lowercase r is equal to theta times the capital letter R, which is the what? Radius of the sector divided by what? 360, which is this. Then our theta was given as what? 90 degree, which is the angle of theta at the center. Then what we simply do at this point is to substitute into the formula. So in the place of lowercase r in this formula, in the place of lowercase r, what we simply put, we put theta capital R all over our 360. So this is now our formula that we'll be using. Exactly, same thing as this one here. So let's start solving. So pi is what? 22/7 times theta is what? 90 degree times our radius of the sector, which is equals to what? 14 times what? 360 divided by 360 what? Times the slant height, which is also what? 14. So let us carry out that simple arithmetic operation. And this is it. What we simply do at this point, we multiply all the numerator. 22 times 90 times 14 times 14 is 388,080. Then, let me wipe my screen. Then, what we simply do next is what? 7 times 360 is equals to 2,520. So what we simply do, we carry out the basic operation here. 388,080 divided by 2,520 is equal to 154 centimeters square. So that's the area of the what? Curved surface of the cone. The area of the curved surface of the cone. So that's all we will take for today. I want you to have a thorough understanding of this class. Go back, replay it over and over, and grab the relationship between a cone formed from a sector of a circle and the sector of the circle. So for your assignment, you solve this problem for me. A sector of a circle of radius 7 centimeters, subtending an angle of 270 degrees at the center of the circle, is used to form a cone. Calculate A, the base radius of the cone. B, the area of the base of the cone. Thank you for being part of my class. God bless you. Have a nice day. Stay safe.